Hello students, welcome you all to the session for Solutions of GATE 2022 afternoon session, Strength of Material subject for Mechanical Engineering aspirants. Students, when we go with the first question, the rigid beam of AD of length 3A is equal to 6 meter, that is 1, 2 and 3 with a frictionless pin joint A and supported by two strings as shown in the figure. String BC passes over two small frictionless pulleys of negligible radius. All the strings are made up of same material and have a equal cross-sectional area. Force is 9 kN which is applied at a point C, and resulting stresses in this string are within linear elastic limit. The self-weight of the beam is negligible with respect to the applied load. Assuming small deflections, the tension developed in the string at C is dash kilonewtons, round off to 2 decimals. So basically, if I draw a free body diagram, the reaction at point A, this is RA. A tension from point B and one more tension from point C. And at point D, this is the conditions which will be known. And at the top, this tension will be acting downward. This is a point A. This is A and this is A. Let this be T dash. 2 meter is the length given of each bar. When I take moment about A is equal to 0, T into 2 minus T into 4 minus T dash into 6 plus 9 into 4. Force is 9 kilonewton given to me. So obviously when I take that 9 kilonewton force, where it is acting at a point C like this, right? This is the force, black color line, 9 kilonewton. So from here, T plus T dash is equal to 6 kilonewton will be the answer. Now when I take a beam ABCD, it is rigid and it will remain straight. So if the deflections are in this way, this is the condition. A, B, C, D. So here I can write delta B by 2 is equal to delta C by 4 is equal to delta D by 6. Delta D repeating, delta D by 6. Delta D is equal to T dash A by AE. Delta B plus delta C is equal to T into TA by AE. Let this equation be 1, this is 2 and this is 3. From equation number 2, delta B plus 2 delta B will be equal to 3 TA by AE, right? So delta B will be is equal to TA by AE. 3 and 3 gets cancelled. So from equation number 2, 3 and a fourth equation. Let this be the fourth equation. From 2, 3 and 4, T dash by T is equal to 3. Substitute back this in equation number 1. Equation number 1, you will get T is equal to 1.5 kilonewton. This will be the answer for the given question. So he asked dash kilonewton. This will be 1.5 kilonewton. Moving to the next question. Question number 2. A shaft of length L is made up of two material, one in the inner core and other one in the outer ring. Two are perfectly joined with each other. No slip at the interface. Along the entire length of the shaft, the diameter of the inner core is di and the external diameter of rim d naught, as shown in the figure. Modulus of rigidity of core and rim materials are Ga and G naught, d naught equal to 2 di, Ga equal to 3 G naught. When the shaft is twisted by application of torque along the shaft axis, the maximum shear stress developed in the outer rim and inner core turn out to be tau naught and tau I. All the deformations are in the elastic range and stress strain relations are linear. The ratio of tau 1 or tau I by tau naught is. So here the given question is this. A cross section is circular section, theta naught and theta I. When I write the formula, TL by Gj is equal to, this is the condition, L naught is equal to Li. Now, T naught by Ti is equal to G naught by Gi into J naught by Ji. We know that T naught by Ti is equal to 1 by 3, pi by 32, d naught power 4 minus di power 4 by pi by 32, di power 4. T naught by Ti is equal to 1 by 3, d naught by di whole power 4 minus 1. T naught by Ti is equal to 1 by 3, d naught di. D naught is 2 times di, so obviously this will become 16 minus 1. T naught by Ti is equal to 15 by 3. We also know tau naught by tau I is equal to Ti Ri by Ji by T naught R naught by J naught. So tau naught by tau I is equal to Ti by T naught, di by d naught into d naught power 4 minus di power 4 by di power 4. Substitute ma, tau naught by tau I is equal to 3 by 15, 1 by 2, 16 minus 1. 16 minus 1. You are going to get around 1.5. Tau naught by tau I is 1.5. This will be the right answer for the given question. This is the right answer for the given question. Moving to the next question. A shaft AC rotates at a constant speed which carries a thin pulley with a radius of 0.4 meters at end C. This is the condition. Drives a motor and is coupled at the end A as a shaft that implies a torque of mz about the shaft axis without causing any bending moment. The shaft is mounted on narrow frictionless bearing A and B, where AB equal to BC equal to L, that is 0.5 meter. The taut and slack side tensions of the belt are T1 equal to 300 Newton, T2 is equal to 100 Newton respectively. The allowable shear stress for the shaft material is 80 megapascal. The self weight of the pulley and the shaft is negligible. Use the value of pi. On screen virtual calculators available. Neglecting shock and fatigue loading and assuming maximum shear stress theory, minimum required shaft diameter is dash. Right. This is the given condition. Here, when you are talking about this question, When you see this shaft, it is in the 3 dimension. The two tensions T1 and T2, lengths LL, and when you talk about the twisting moment, M2 is equal to T. So twisting moment, what happens, ma? He has given T1 300 and T2 100, 300 minus 100 into a distance of 4, which will be the radius. Like how I am taking is, if this is the condition, 300 Newton, 100 Newton, radius is 0.4. So 0.4, which you are going to get 80 Newton meter, M2. Now, when I talk about an FBD, there is some moment at point A, the reaction is RA, at B, RB, at C, there are two tensions, T2 and T1. I'll show you. This is the condition. Right? Now, moment about A is equal to 0 minus RB into 0.5 plus 400 into 1 is equal to 0. RB is equal to 400 by 0.5, which will be equal to 800 Newton. Positive, right? Summation Fy is equal to 0. Ra will be is equal to sum of upward and downward, same 400 Newton. When we are talking about the shaft, maximum shear stress in the shaft and bending and torsion due to bending and torsion is 16 by pi d cube root m square plus t square. Using shear stress theory, tau max is less than or equal to allowable stress, 16 by pi d cube into root of 200 into 10 cube whole square plus 80 into 10 cube whole square. He has given the tension, right? So from here, which should be less than or equal to 80 allowable stress. You are getting 23.936, which will be less than or equal to D. So whenever he is asking you to opt the allowable dia, it should be around 23.94 mm. 2 marks question, like 23.936 will be the absolute right answer for the given question. Moving to the next question. A linear elastic structure under plane stress condition is subjected to set of loading 1 and 2. The resulting stress at a point corresponding to two loadings are shown in the figure. If these two sets of loading are applied simultaneously, then the net normal component of stress sigma xx is. The loading one direction is given to you and the loading second direction is also given to you. When you are talking about this, let this be x1 an angle of 45 degrees. If I draw a diagram, x direction, tau xy, sigma y, tau xy, sigma x, tau xy. We know the transformation equation, right? Sigma x is equal to sigma x1 plus sigma y1 by 2 plus sigma x1 plus, you have written plus already, minus sigma x2 x1 y1, this is also x1 y1 by 2 cos 2 theta plus tau xy sin 2 theta. Sigma x 0 plus sigma by 2 plus 0 minus sigma by 2 cos minus 2 into 45 degrees. Shear is 0. Sigma x is equal to how much you are going to get? Sigma by 2. So when you are taking about the first diagram, this is the condition. If for the second time, what happens if I draw an FBD? Sigma plus x direction tau xy, y sigma x sigma y. So for inelastic material, what I'll write? Sigma x equal to sigma plus sigma x. That is sigma plus sigma by 2, which will be 3 sigma by 2. So obviously, what will be the answer? 3 sigma by 2. Option A will be the right answer for the given question. Next question. Which of the following is defined as ultimate tensile strength obtained by the stress strain test on the metal specimen? The maximum load attained divided by the original cross-sectional area. The stress value where the stress strain curve transitions from the elastic to plastic behavior. A maximum load attained to be divided by corresponding instantaneous cross-sectional area. The stress where the specimen fractures. Basically, ultimate tensile strength is maximum area to maximum force to original area. Stress calculated before or immediately before fracture or before failure is called as fracture. So obviously, a maximum load attained divided by the original cross-sectional area, option A will be the right answer for the given question here. Option A will be the right answer for the given question. By this, we have completed the questions of strength of material set 2 afternoon paper. Thank you, students.